Whenever we divide with fractions, we're going to use this rule. It's called keep the first term, change the operation from division to multiplication, and flip the second. So I want to use this example on number 19 because it's got a little bit more going on than just keep, change, flip. If you look at number 19, we're going to see here that we have a mixed number and we have a proper fraction. So we got a mixed number and a proper fraction. So what I want to do is I want to look at this one here and I want to write it as an improper fraction. So whenever we do this, we know what doesn't change is the denominator. So let's just go ahead and write the denominator. And I'm going to write the second term down because we're not going to apply on that rule yet. In order to find my new numerator, I'm going to say denominator times whole number. In this case, it's 2 times 2 is 4. And then you're going to take that product and add it to the old numerator, which is 1. So 4 plus 1 is 5. Now we're good to go. So what we're going to do is we're going to apply that rule of keep the first, change the operation from division to multiplication, and flip the second. So let's do that. We got 5/2 times 4/3. Now, you can always wait till the end to reduce, but it's always easier to reduce when the numbers are small because then you're less likely to miss a number and get it incorrectly. So this is the question. Is there a number on top that will reduce with the number on bottom? Well, 5 is prime, so it won't go in 2 and 3, so I'm not worried about it. 3 is prime, and it won't go into 4 or 5, so that doesn't work. But I do see I have 2s and 4s. So let's rewrite it. I know that 2 is prime, so I'm going to leave it like that. But 4 is 2 times 2. So now I see that, I got a 2 that will reduce with the 2, and it goes into itself 1 time. So now we have 5 times 1 times 2 all over 1 times 3 ends up being 10/3. Okay, so this is an improper fraction. This would be my final answer unless you were asked to write it as a mixed number. So if you're asked to write it as a mixed number, because that's what mixed numbers and improper fractions go back and forth. However, proper does not. All right, remember, proper means the numerator is smaller than the denominator. So let's write this. So this is improper. Let's write this as a mixed number. What don't change? The denominator. So I'm going to go ahead and write that 3. So now I got to find what's going to be my whole number here, because that's how a mixed number is. Mixed number is whole number times proper fraction. And then I got to find my new numerator. All right. So the question is, our denominator, and in this case it's 3, times what will get close to, approximately equal to, that 10, the old numerator. And the reason why I'm going to say approximately close to is because if it would equal it, or you can find a number that go into it, then that means it would reduce down and there's no need for this stuff. In this case here, it won't reduce down. So my question is 3 times what will get me close to 10? Well, I know 3 times 3 is 9. Perfect. So my new whole number here is 3. Now, we need the remaining part. 10 minus that 9 is 1, so that's my new numerator. That's one way to do it. Let me show you another way. If I was trying to take 10/3 and write it as a mixed number, I can write it. Remember, the bottom number always goes on the outside of the doghouse. This is long division. 3 goes into 10 3 times. 3 times 3 is 9. Subtract, get a remainder of 1. All right, so now we have our denominator, we have our whole number, and we have our new numerator. So that's another way to do it. I would like to do one more fraction with you. I'm going to do a messy one just because they are fun. Let's do a complex one. So let's see if I got room on another piece. Okay, I'm going to take this problem. I'm going to do 23. I'm going to bring it down here, okay, and then I'll scroll. So 23 says we have 3/5 divided by 3/4. And it's all divided by 4/5, all divided by 1/1/9. All right, so let me scroll down. Oops. We'll just have to rewrite it some more. Let me rewrite it. 3/5 divided by 3/4, all divided by 1/9. Let's see. 4/5. All right. So I just rewrote this. So this is a complex fraction. We have a fraction divided by a fraction, then divide it again by a fraction divided by a fraction. So what we need to do is we need to focus on one part. Let's focus on this term first. Let's clean it all up. And then we're going to clean all this up, and then we can apply the rules. So what I'm going to do is rewrite this first one. I'm going to come over here and let's call this column A, and let's call this column B. So let's do A right here. Make it a little bit easier. Whoops, not a straight line, but. So I got 3/5 divided by 3/4. So I just rewrote it where it's easy to work with. They're proper fractions. There's no extra work needed. So let's apply that keep, change, flip rule. So I got 3/5 times 4/3. And I asked myself, is there a number on top that will reduce with a number on bottom? Sure. 3 goes into itself once. So now I got 1 times 4 over 5 times 1. So it's 4/5. All right. So now I got 4/5 here. I'm going to bring down this division. Now let's clean up this other side. Let's do B. Well, B, we're going to have a little bit more work to do. We got 4/5 divided by 1/1/9. So what I'm going to do is turn the mixed number into a improper fraction. And I want to clean this up just a little bit because the way it's written is not exactly correct notation. There we go. So I need to change this to an improper fraction. So what don't change? The denominator. And now I'm going to say 9 times 1, the denominator times the whole number. So it's 9 times 1. And then take that product and add it to the old numerator. So 9 times 1 is 9, plus 1 is 10. And now I have this. All right, it's 4/5 divided by 10/9. Then we're going to keep, change, flip. So I got 4/5 times 9/10. All right, so now what I'm going to do is I'm going to see if I can reduce. Well, 5 is prime, and the numbers on top is made of 2s and 3s. So I know 5 is not going to go into it, so I'm not worried about it. But what about 10? 10 is a product of 2 times 5. So 2, it won't go into 9 because 9s are made of 3, but 4 is made up of 2. So I'm going to rewrite this one more time. So I got 2 times 2 over 5 times 9 over 2 times 5. And I see that my 2 will reduce, right? And this gives me 1. So what do I got now? I got 1 times 9. 1 times 2 times 9 is 18. I got 5 times 1 times 5, that's 25. So I got 18/25. Almost done now. We got it all cleaned up. Now let's apply that keep, change, flip rule on the final part. So 4/5 times 25/18. And let's reduce. Well, 4 is made up of 2 times 2. 5 is prime. 25 is made up of 5 times 5. 18 is 2 times 9. So we're done. I got a 2 that reduces with a 2. I got a 5 that reduces with a 5. And now I'm left with, and I can put 1s in here. Now I'm left with 1 times 2 times 1 times 5. That gives me 10. Got 1 times 1 times 9 is 9. This is my final answer. It is an improper fraction. So if you're asked to convert it to a mixed number, you can. So the denominator don't change. 9 times what? 1. That gives me 9, right? Because we're looking for the 9 times what? That gets me approximately equal to 10, and it was 1. 1 times 9 is 9. 9 minus 10 is 1. So this is my mixed number. And that is division using with fractions.